Welcome back, everybody. It is all about problems finding expressions and equations from words and getting them set up, not necessarily solving. Let's look at this first one here. What is the expression for the product of a number and 8? Well, there's two ways to do this. When you're talking about product, we mean multiply. We can just say 8n, or we could say n times 8. There's lots of ways to do it. You can do 8 parentheses n. You could do 8 times n, but normally that's not done in algebra because the x might be, the multiplication symbol might be thought of as a variable. But any of these really work. Most common is this one right here. Let's look at another one. What is the expression for the quotient of a number and 11? Okay, n over 11, that shows the quotient, or we can use the actual division symbol, n divided by 11. All right, getting a little more complicated here. What's the expression for twice the sum of a number and 4? Twice the sum of a number and 4. Whenever you see the word twice, we're going to think 2. But since they have kind of the phrase here, sum of a number and 4, that's going to go in parentheses. A number and 4, that's the sum, and we're taking twice that. Because I say twice at the beginning of the phrase, we put the n plus 4 in parentheses. Equivalently, this is 2n plus 8 if I were to distribute, but this is actually what we're after. All right, how about this one? 4 less than 2/5 of a number is 32. Okay, we see the word is. As soon as you see that in a math phrase, put equal sign. So something's going to equal 32. 4 less than number, even though this is at the beginning, whenever you see 4 less, 5 less, 7 less, it's always subtracting that amount, and it's going to come at the end. So if I'm saying 4 less, I'm subtracting 4. 2/5 of a number, 2/5 times an unknown variable. I'll use n for number, could be any variable, x, y, z works. But this one we're setting up an equation, so this is actually an equation, not an expression. Let's look at another one here. What's the expression for 7 less than the quotient of a number is 6 and 12. 7 less than the quotient of a number is 6 and 12. Okay, I think we got a little bit of a typo here. Meant to put the word and in front of 6 and the word equals in front of 12. So we're actually doing this. It's supposed to say this. Yeah, the word equal here. Let's get the right word here. There we go. Just fixing this. 7 less than the quotient of a number and 6 is 12. Okay, so we see the is again. Equals 12. 7 less, I'm subtracting 7, and the quotient of a number and 6. N divided by 6. There is our equation. The quotient of a number and 6, and it's 7 less, and we're equal to 12. All right, let's look at another one here. What is the expression for 2 less than the product of 8 and a number is 3 more than the number? Okay, getting a little more complicated here. Now we have, still dealing with an equation. I know we have an equation because of that word is. We know we're going to have to apply an equal sign. So let's get that set up here. 2 less than the product of 8 and a number. I see the phrase 2 less, so I am subtracting 2. The product of 8 and a number, 8n, and then is 3 more than the number. So here's the number, and I'm just doing 3 more. 8n minus 2 equals n plus 3. All right, let's get some application problems here. It says the voltage equation is V equals IR. V is the voltage, I is the amps, R is the resistance. Write an equation for a refrigerator that needs 8.6 amps. So I'm just going to rewrite this. V equals I times R. and then just knowing what variable 8.6 goes in for. 8.6 is the amps, so we're just going to substitute that in for I. V equals 8.6 times R, and that is the setup for the equation. We're not solving it. We don't have any other information other than just setting it up, and so know what it looks like. Now, if somewhere else in another problem, if they gave us R, if they gave us V, we could solve for the other variable. Let's do another setup here. Okay, a little complicated here. Fuel wood is measured in cords, where the number of cords equals LWH divided by 128, where L is length, H is height, W is width of the cord. The length of a cord is 10 feet, and the width is 32. What is the equation that we needed to find the number of cords H feet tall? Okay, so kind of a weird setup here. Number of cords is equal to length times width times height. We're dividing that by 128. Alright, well, they give us L, 10. That goes in for length. They're going to give us a width, 32. That's going to go in for W. If we take 32 times 10, we get 320. So that's going to simplify to this, 320. They don't give us H, so we're going to leave H in there, divided by 128. And we can just kind of leave it as is. 320 over 128 does reduce, but for our purposes here, we'll just leave the equation as is. So go one more here. Dawn drove a motorcycle in a race. She averaged 25 miles per hour and began a half hour ahead of the other riders. Let D represent Dawn's distance driven in miles. Let T represent the number of hours since the other drivers began the race. What is the equation to show the distance Dawn drove in T hours into the race? All right, let's first go back to D equals rate times distance equals rate times time. R equals D equals rate times time. This is a common equation used in physics. You can compute anybody's distance if you take the rate and multiply it times time. Alright, so we're making an equation for Dawn here, but it's going to be a little bit more complicated than rate times time. We know we can put 25 here is the rate miles per hour. That's going to go right here. But she began driving a half hour, 0.5 hours ahead of the other drivers. So D is the distance in miles, T is the number of hours. So instead of just doing T, we got to do T plus 0.5. Because she was, remember what it says, she began at 0.5 hours ahead of the other drivers. When you see that word ahead, we got to add that many more hours to the time of compared to the other riders. So a little bit more, it comes from distance equals rate times time. It's a little more complicated than that given the situation. D equals 25 times T plus 0.5. Well, that's all our examples. Thank you for watching.